to talk about here is shifting security left, and we're going to talk about what that means, what security means in an age of agile methodologies and DevOps practices. So I'm going to tell you a little bit about myself. My name is Chris Merkel. I do security stuff. I've been doing security stuff in a lot of areas for quite some time. Right now I work down the street at Northwestern Mutual. I've lived here in the Milwaukee area my whole life. I really love it here. And I was thinking about what to put on what would be relevant on my bio slide. And given the vintage hacking challenge, I figured I'd put up my first computer, which was a Commodore 64. Typical disclaimers. So these are my opinions alone, except the bad ones. I stole those from somebody else. And that third bullet point here is something I really do want to stress, is that a lot of what I'm doing here is highlighting the work of other people. What I'm trying to do is bring that together in a cohesive way that helps us how to understand how to solve some security challenges. And as a result, I try to do good attribution. I try to call out people's contributions, and if I don't do that, at me. I didn't give you what it, like, digitally at me. I mean, it's like, just come talk to me. So here's our agenda. You'll notice across these bullet points that only one of them actually has to do with technology. I really appreciated the keynote from last night. And if you were in the keynote last night and you were paying attention, you'd realize that there were really two things being talked about. The first, on the surface, you might come away learning something about NAND flash memory and translation layers and things like that. But what was really being talked about was questioning our assumptions about what we do and why we do it. So I really appreciated that. That kind of warmed this up a little bit for me, because I'm going to kind of talk about that too. We're going to talk about what it means to try harder, what it means to eventually fail when you've tried harder. I'm going to try to provoke an existential crisis amongst all of you at 10 in the morning. We'll break it down before I build you up a little bit. Then we're going to talk about giving up our desire for control, what it means to trust other people, become an enabler, a healthy enabler, not the kind of enabler I saw at the Safe House last night. And then finally, we're going to talk about how we make modest improvements to security through a couple of smart technology decisions. Okay? So first, let's clarify what we're talking about here when we talk about security failures. Typically, security failures, in my mind, tend to come down to three basic problems: code, configuration, and people. What we're going to talk about first is we're going to talk about people, not in the traditional sense of, people clicking on phishing and things like that, but the kind of people you got to work with to actually achieve, good outcomes in security. Then after that, once we get into the technology, we'll talk a little bit about code, we'll talk a little bit about configuration. So, as we start to talk about people, we have to talk about the natural life cycle of information security in a typical organization. And in most organizations, when you get started in security, so I try to be randomly interactive. How many of you are working in security at a company where you are one of the first people in security who are doing security at your company? Just out of curiosity. All right, cool. Congratulations, and I'm sorry. Depending on the situation and the circumstances that brought you to that organization, you may or may not be starting out with a good working relationship with the people you're working with. And so a lot of the first things you do in security is try to make sure that the rest of the organization actually understands why you're there, what value you're bringing to this conversation, and the thing that we always talk about is being involved in the conversations, getting a seat at the table. And if you're good at that, if you're good at managing those relationships and getting a couple of wins, you are going to get a seat at the table. So congratulations. This is how I feel sometimes when I find myself having a seat at the table. Like, you know, I have no idea what I'm doing. So now as security professionals, we come in and we look at a situation and we go, all of this stuff is broke. We have to fix it. And so we're going to secure everything. We will bend all of the systems and all this technology to my will. I'm going to be on every single project because I am the security subject matter expert, and I will be there. I will be at every project meeting, every status update, and I will make sure this all happens. And I'm also going to make sure that I have to sign off on everything. And I'm going to weasel my way into the change management, if you got change management, and I'm going to make sure that I sign off and approve on everything along the way. I'm not really going to test a whole lot along the way because that's what a penetration test is for. We'll do that at the end. And don't change anything after you've built it because I got other projects I have to move on to. Okay? That's not going to work. And in a lot of ways, I'm describing, as I talk about project methodologies, I'm talking about a waterfall methodology where you do things in a set of sequential orders until you reach your desired outcome. So I'm going to say that in waterfall security models, things like angst, cost and delay, and failure, these are features, they're not bugs. So in that traditional security play where you think you can wrap your arms around all of this and actually secure all the things, this is what you come up with. I do humor in the form of Gantt chart. I'm sorry. And I'm also a little sorry because the text is a little small here, but basically what we find is that if you do get involved, you know, we make these decisions on technology projects, and you'll notice here that the time to actually develop it, you know, goes way past your go live date. So at the point in time at which you actually want to put this system into production, all your business stakeholders, they're upset. You've missed your go live date at this point, and then typically what happens is they're going to quickly go and launch, and then security we come back and we say, okay, cool, I have to test it now. You're already live in your production. What do? You run your security test, you know, out of months and months of work, you know, they tell you you got exactly 6 days to find out everything that's wrong with security in this product. Go. So you do some security testing of some kind, typically penetration tests or something like that, where you're kind of working from the outside in, okay? You're gonna spend a little bit of time disagreeing about the actual findings. They're gonna tell you that these aren't problems because they don't want to deal with them. You know, then they start to go through the typical 6 stages of grief. You know, so you get, you know, shock, anger, I don't know what they are, I'm not a trained psychologist. You know, we do a little bit of bargaining, and then eventually they decide they're going to commit to this. You know, they start doing all the remediation work, and then somewhere along the way, you get breached, and that's what happens. And part of the root of this problem comes down to something that IBM pointed out, is that all bugs cost money, some cost more than others. So this is from a classic paper that IBM put out quite some time ago. So when I screenshotted it, it was super pixelated because I think it was made on like WordPerfect or something. The cost to fix a bug in maintenance mode, which we would say is the production phase of a system, costs 100 times more than fixing or avoiding the defect during the design phase of a system. So the original name of my talk is Shifting Security Left. The natural question you might ask yourself is, left of what exactly? Okay, so what I'm going to talk about is going to presuppose a little bit of understanding on how software projects tend to be made and built and things like that, right? So we've got all the way to the left, we have our code, we have two different pipelines. We call this CI/CD, continuous integration, continuous delivery. And I'm going to talk about this in terms of teams that do this kind of work, okay? Now, I know as a security professional, myself personally, I come from a network and infrastructure background. I'm not used to actually dealing with what happens in a development life cycle. You know, developers go off and do stuff, and then they have this big blob of stuff called like code, and then that code goes on a server. Everything that happens before that is either like black magic or doesn't really happen. Or I don't really understand it, because I write bad code, I compile my bad code, and then I just like copy it to a server and I'm done, right? There's nothing else that goes into software development other than that, right? Well, not really. So, in a modern CI/CD system, we talk about information or process moving from left to right. And typically speaking, most of the time that security is involved, we're involved when we're on the right side of things. We're dealing with things when they are about to go into production. We deal with things that are built. So let's say we get to catch it before it goes into production. Typically in security, we want to see a built product. We want to say, I want to make sure that I can test a built product. Call me when you have something I can actually do something with. And it's too late at that point. Because again, if you go back to this IBM statistic, at best, if you're doing really good, maybe you're only costing the organization 15 times as much instead of 100 times as much. So I said I'd talk a little bit about DevOps. This is the basic operating model. I'm really oversimplifying this for the purpose of conversation. And it's also worth pointing out that when we talk about this kind of automation in CI and CD, most of this is application design and build, and a lot of this is deployment and infrastructure and things like that. It's also worth pointing out as we move into new operating models with cloud and things like that, this isn't just application code. We're moving to a place where code drives everything. Okay, so if you've done any work in cloud spaces, you realize that the basic model of being able to like point, click, make a server, that's neat, but that's not the future, that's not the operating model. The fact of the matter is I can build an entire data center in code, and I can push one enter key on my keyboard, and I can give you a whole data center. Nobody's racking and stacking anything, nobody's plugging in wires, nobody's manually installing operating systems. All of that is represented and instantiated by code. That's the kind of environment we're talking about operating in. So let's talk a little bit about DevOps. What is DevOps? And for those of you who flinch a little bit when I use industry buzzwords, sorry, but I don't like the word cyber, but I'm stuck with it. So we all have to deal with those kinds of things.
Just keep the Gantt charts coming. We'll forgive you.
DevOps is first and foremost, is a cultural philosophy, principle, practice. It has a set of tools, but this is really important because anybody who says, I have this tool, therefore I'm DevOps, is doing it wrong. If somebody says that the way I'm doing DevOps is the right way and you're doing it different, therefore you're wrong, is also wrong. Because DevOps, Agile, these are methodologies, approaches, and ideas that need to be crafted and adapted to the way your project demands, the way your business operates, the way you structure your teams and things like that. But the outcome is really the only way, if you want to know if you're successful or not, the measure is high velocity. Can you deliver applications and services at high velocity? Now, Wolf asked me, can I keep the Gantt charts coming? I'll go back to at least the one I have, because I don't have any more than that. This is not high velocity. This is low velocity. Because in my fictitious chart that basically sums up about every enterprise project I've worked on. You know, if we can get a major enterprise system out in less than 6 months, we're awesome. Okay? And this is, again, left to right. They've planned everything out way ahead of time. They're executing on it. They're late. It takes forever. The time you actually realize value in this equation is here. So the whole point of Agile is actually getting to deliver systems and services quickly. So what are the cultural philosophies that are inherent in this? First of all, we're having small multidisciplinary teams who work autonomously. They do everything in small increments. And they do this by getting continuous feedback and continuously testing, adapting, and revising. And in this idea of a small interdisciplinary team, what's not stated is that this doesn't work in a large monolithic technology organization where one team is responsible for their work and then they throw it over the wall to the next team, who throws it over the wall to the next team. That's how we deliver systems in the low velocity way. So IT broadly has realized that this is a problem. This is why we are moving to Devops. It's not just the flavor of the week here. So in terms of practices, as I indicated before, we talk about everything as code. I had the fortunate opportunity to take a SANS class this last year in cloud security, and in it, we had one large log formation template that built that whole VPC. And when we were done, I executed one script and I destroyed an entire data center with one command. That was pretty awesome. As a security professional, it's also a little scary. We have to talk about automated provisioning, because as we deliver tools and functionality, we have to deliver these to people in a way that adapts to them, that gets out of the way, that delivers them the functionality they need without having to come and ask or to place an order. A lot of how we do IT in general is order creation and order delivery. You got a ticketing system, a self-service request system, a paper form, who knows what. And somebody somewhere fills out a form that gets routed to a person, that person approves it, and then it goes to this other person who then approves it, and then it goes to this other person, and this other person pushes a bunch of buttons to affect the change, and then eventually somewhere along the way you get delivered some sort of access to something. And in a high-performing organization, that could happen in a couple of hours. And I'd say this is where we have to have the existential crisis. Don't do that. Figure out how to give people what they need based on who they are and have it ready. That's it. A lot of these practices also include things like incremental testing, continuous monitoring, and baked-in security. Now, as a security professional, if you find yourself in a situation where you get dropped into some sort of Agile or DevOps practice, this is essentially what tends to happen. Okay? The security team doesn't quite get what's going on here, right? The developers, they see that concept of a pipeline that I talked about. They see it as an assembly line, a factory, a way of moving things along to incrementally create and deliver features, functionality, stuff. Security looks at all this and they see Jackson Pollock. That creates some problems. So, as a security professional, I think sometimes it helps to talk a little bit about, I've talked about these things in kind of, vague and abstract terms. I want to talk a little bit about a high-performing DevOps team. So we're gonna do a little bit of a case study here. So we've got this company named Convene Security. They're $1 billion in revenue, 3,600 clients. They've got unified cross-functional DevOps teams. They're investing in top talent. They're using things like Jira, HipChat, Azure Cloud, and they're creating software, and they're delivering that software to thousands and thousands of endpoints across the globe with release cycles that are measured in days. If they need to add new functionality, they have the discipline as a team to write, test, integrate, and deploy that software day over day over day over day, thousands of endpoints. And we're not just talking about, consumer grade stuff. We're talking about people in food service, hospitality, healthcare, and they manage to do that without killing their employees. Their employees have awesome work-life balance. They rarely have to work nights and weekends. This is what a high-performing Agile and DevOps team looks like. They're also a cybercrime gang. Okay? By, customer, I actually meant victim. And I mean, honestly, what's the difference between infection and deployment? You're still just getting software from point A to point B, right? You gotta be good at it. You both have a financial motive, right? And yes, they've been plundering clients across food service, hospitality, financial services, gaming. The list goes on and on and on and on. And if you don't get the unicorn thing, it's, Silicon Valley billion-dollar valuation kind of a thing. So, if we take a step back and we ask ourselves, is this Agile and DevOps thing like a passing fad or what? Let's talk about the people who truly have the purest of economic motives. Who are they? Criminals. So if this works for them, there's probably something to it. We should probably stand up and pay attention. Because if it didn't work, they wouldn't have to do it. They don't have senior leaders who feel like they want to get on the front page of InfoWorld with the cool, neat thing they did and sandbag their organization with a bunch of junk and technology process to do so. No, their whole job is to make money and make money quick and effectively. Okay? And so this is the result. This is how I felt. Because in parts of the organization that I'm responsible for, this is my adversary. My adversary is more agile and can adapt better than me. And I envy Jack Donaghy and his seemingly miraculous endless bottle of whiskey. The other thing I have to keep in mind here is, as I said before, a lot of people like to throw around buzzwords and say that we are agile, say that we do DevOps and things like that. And I did a little bit of research into this, and basically a lot of teams that say they are agile often don't really have the technical practices that come along with this. So I tend to question if everybody is as agile as they claim they're being. Now, as a security professional, that's actually heartening a little bit, because what it means is that you still have an opportunity to wrap your head around what's going on here, adapt, and start to help. So this kind of concludes the part of my talk where I wanted to break you down a little bit and tell you that this is here to stay. It's going to require a significant amount of mindset shift about changing the way that we think about these things, questioning old assumptions about how we do security, how we deliver security, who our customers are, and things like that. So now I'm gonna shift a bit into some of the technical things, and here's what we're gonna talk about. We're going to talk about training, threat modeling, requirements, architecture, code quality tools, and why I make poor life decisions. So, I'm not going to skip back like 10 slides, but one of the things I had on that graph as we talked about the left to right from creating to delivery, the one thing I don't really have on that slide, because I did indeed take that from somebody else, is that before we do any of this, we have to make sure that everybody is capable of doing the job they have in front of them. Okay? So let's talk about training. And I know in a lot of organizations, training is a difficult thing to ask for. But I'll tell you that I've been working in technology for over 20 years. And there is no time in history that I can recall where we had as much free training and resources available at our disposal than we do right now. And on top of that, the place where the best and largest quantities of training is in this space with the types of tools used in Agile and Devops shops, cloud services, continuous delivery and integration, and things like that. So, first of all, we need to make sure that our developers actually know how to write secure code. We should, start with that. There's training available for that. If you don't understand, if I say, we need to do something with AWS Lambda, and you don't know what that is, Amazon has a series of things that explains to you what that is. It's just Python code. That's got a cool name. It's called Lambda. Microsoft and Azure, they've got a huge learning portal. There is so much good stuff available that if somebody were to come to me and say, well, I'm sorry, but my organization just does not send me to training, I question whether you're trying hard enough. So when we talk about shifting left, the first part is long before we ever put hands on keyboard and start working with technology. The next thing is we need to start talking about threat modeling, because in a traditional software development lifecycle, we start with requirements definition, and as security professionals, we are trying to tell people what types of risks they need to avoid, what types of negative outcomes they need to avoid. And in order to do that, we actually have to construct a threat model. If you have ever had a conversation in security where you show up and you start with, you need to use this technology, and you get pushback and argument and things like that, as security professionals, a lot of times we say to ourselves, well, they just don't get it. No, there's a good chance they actually do get it, but they understand their data, they understand their business process, and they're not convinced that the risk that you're trying to get them to invest in is actually the biggest risk their system faces. That's why we start out with threat modeling. And what I'm showing here on the right-hand side of the screen is threat modeling as a game. I've read plenty of books on threat modeling going back several years. If you would have asked me 3 to 5 years ago, should we do, threat modeling with, normal teams, I would say no, that's like an exercise for like governments and militaries, because it's going to take you days of planning and things like that. Threat modeling can be lightweight. One of the best lightweight ways to do this is through gamification. So Microsoft has their elevation of privilege. University of Washington has security cards, a similar game. I love the Microsoft game because it's actually licensed free, like really, really free. So you can print cards. If you wanted to like sell these cards on the internet and make money, you can do it. Basically it uses the same suit as a normal deck of cards, but what you get into is everybody looking at different ways that something can fail. So you start with a real basic, you pick some key transaction, some high-risk transaction that this does, and you play this game, and it eventually helps you to spawn conversations around what you need to do to improve your security. if you're progressing from there, you can start to actually build threat modeling into your code. There's an open source project out right now called ThreatSpec that actually allows you to document your code with security requirements and allows you to create really cool graphs and things like that. So now that you've constructed your threat model, now we need to actually translate that, because the threat model tells you what could go wrong. The next thing is the question, what do I do about it? So this is where we have to start delivering requirements. Now again, that threat modeling game, if you're good at it, they play that without you. Okay? You do not need to be the dungeon master of threat modeling. Okay? You teach them to play the game, to build their own threat models. You can keep an eye on them, but you enable them. The next thing you do is give them the ability to define their requirements. In application development, I've done a lot of work recently in AppSec, so I'm gonna lean on that a bit heavily in the first part of this. OWASP has the application security verification standard that helps you design requirements in software for how secure software is built. Slack released another tool called GoSDL, the Security Development Lifecycle. These are customizable systems that help you identify security requirements and guide people from threat model to what they actually need to build out as stories and requirements as they build their software. Where do we get some of this from? Well, you can go to, OWASP. Everybody knows the OWASP top 10. Top 10 is great, but it's a list of things you don't do. It's not a list of things to do right. So the list of things to do right is in the application security verification standard. That will tell you, don't have path traversal. ASVS will tell you how to avoid having path traversal, which is a really important point. If we take a step back from the language of code and development, as security professionals, we can't show up to our customers and say, don't have this bad outcome. We have to show up and say, here's how you avoid this bad outcome. Doesn't sound like a major shift, but in terms of how we talk with people, it really does matter. If we start to move into, platforms like services and things like that, we can start by defining some secure architecture standards. So AWS, a lot of people say, oh, the cloud's like the wild, wild west. No, like Azure, AWS, they're doing a better job in helping organizations understand how to do security than just about anybody else right now. Azure has that. Microsoft has their best practices. Okay, so that's on the requirement side. Now, we're finally going to get to the point where somebody puts their hands on keyboard and starts writing code. Because what you've done at this point is you've trained them on how to write secure code or how to do cloud security in platforms and operating systems. You've helped them identify the requirements, which is the list of work of things they're going to do to actually do this. You've done this based on standards, benchmarks, frameworks, all those kinds of things. Now, the first thing we do is we have to help them identify their bugs. Okay? So we have to make this seamless. So again, I talked about auto-provisioning. Developers need to be able to just consume these kinds of things and find their own bugs. Okay? All the code quality stuff that goes into AppSec, that gets built into templates. You can template these things out. They need to be able to find the bugs because developers are used to working in an environment where they write code, they see how they messed up their code, they go to Stack Overflow to ask other people how to not mess up their code, they copy and paste that into their own stuff, and then they try again, which is kind of cynical, sorry. And they learn by making basic failure fix over and over and over again. In security, we have to be able to do the same thing. We have to give them the ability to surface all of their own bugs so that they can figure out how to fix their bugs. So that means, building this into those automation processes, continuous delivery, continuous integration. That's things like Jenkins, Travis CI, GitLab, etc. As a security organization, we still have to be able to drive accountability. So all the data that comes out of these systems and tools, we do need to kind of keep an eye on. There is an accountability aspect to this that we have to maintain. And then finally, we can get to a point where when we've got a lot of this built into our development life cycle, we can start to warn people when they're proceeding towards production with something still being wrong, whether that's a code flaw. It could be a misconfiguration in an EC2 instance or an Amazon S3 bucket that's open. List goes on and on and on. We can warn them so that when they try to build and push their software into test or push their software into a production system and say, hey, just so you know, this is still kind of broke. Okay? That might be an approach in some organizations because if you go back to your threat model and you look at your actual vulnerabilities, the business opportunity is such that you go, yeah, at our level of maturity, we're going to have to let some bugs go into production. But at least you know about them. Then as you mature, you start to break things. Oh, I'm sorry, this server is out of spec, this code's out of spec, you're not going to production. We're going to stop this from happening. Along the way, we've got some code quality tools. We've got you start with the actual editor, and for your developers that use an actual like IDE and they're not just using like Vim or something. Things like SonarLint, Fortify Security Assessment. There's a whole bunch of tools that do static analysis, so they're looking for patterns of, or we call them anti-patterns, patterns of bad code. So SQL injection, cross-site scripting, cross-site request forgery, things like that. Dynamic analysis, if you're a security professional, you're a little more familiar with this. This is when you're actually interacting with a built application that can transact data with you. And then finally, and this is I'm going to stop and focus on this the most in this because this gets overlooked, is we also need to look at the composition of the software that developers are writing, because how many of you have written an application in Node in any way? By show of hands. Okay, wow, yeah, that's awesome. That's more people than I expected. The first thing you do is you do npm get and the package you want, and then you use that package, and the actual code that you write is like usually like 1 or 2 lines, because you're just borrowing another package, right? So in a typical code base, if you look at the code that you actually write and all the lines of code and the packages you import, the most charitable estimate is that a Node project contains only 20% code that you wrote. The other 80% is code that you brought in from somebody else. And in the open source world, anybody can publish to NPM. And the idea that many eyes make all bugs shallow, I would argue that the 20-year-old OpenSSL vulnerabilities we find suggest that that's not actually true. Now that doesn't mean there's anything wrong with open source. It just doesn't mean it's a panacea, and it doesn't mean that you can just automatically trust it. So that means we actually have to verify the security of these code packages we're bringing in along the way. We have to check for these dependencies. We can talk about delivering golden images. So AWS has this concept of golden AMI pipelines. So you can actually configure your AWS accounts to have pre-built images that are hardened for security, that meet CIS security benchmarks, things like that. And in a more mature organization, you actually stop patching things. Sounds kind of crazy. You don't actually patch running instances, you patch your golden image, and then because you're so good at building and delivering that software and deploying it out, you literally, like I said before, I can take down an entire data center, you just destroy an application and you rebuild it. You deploy new servers and you put your code on there, and then everything works, and that is grossly oversimplifying how that works, but that's the concept. We also shouldn't overlook containers. So how many of you have used a Docker container or Vagrant or something like that? Cool, all right. I love Docker, right? Docker is so fantastic because no longer do I have to mess with dependencies and all that junk. I download one image file and I say, Docker up. And everything works. It's so cool. we have to scan these containers for vulnerabilities. We put these things into production. They have built-in libraries. They're kind of an abstraction of the operating system. We need to make sure that what's running in there is good. Vulnerability management. So in this type of an operating world, vulnerability management is more than just scanning your assets, typically servers and desktops, and finding missing patches. Because if you're operating in this kind of a model, you should actually know what vulnerabilities you have because you know the relative age of the templated resource, that golden AMI, that template container, the template that it came from. You know the security posture of that. You can infer from that the rest of the vulnerabilities that are instantiated from that. So if your golden image is 6 months old, heaven forbid, you know that all your servers have 6 months worth of vulnerabilities. Now, you can still patch individual instances of servers, but you can also patch that golden AMI. The other thing is, as we're giving away control using things like CloudFormation, we're not just telling developers they can do whatever they want. We give templates, and we have the ability to inspect these templates. Templates in CloudFormation are YAML, it's just a basic descriptive language, and we can audit for obvious dumb stuff. If you should never have port 22 open to the internet, you can code lint for port 22 in a CloudFormation template. If your CloudFormation template is spitting out an EC2 instance, you can say, is it spinning out my EC2 instance or just some rando one from the AWS instance store? You can scan your containers. And then, of course, the other thing you could do is, if you use a modern vulnerability scanner in your environment, Qualys, Tenable, Rapid7, all of those have APIs. So at every point when somebody is deploying code out to production, you can interrogate the API of the vulnerability scanner you have in your environment already and ask it, is this environment still authorized to run in, based on its current state? And if it's not, break it. Because you want your developers to force a conversation and say, why is my underlying environment broken? And then they can work together as that single cohesive team to go and make things right. We can talk about incident response. Okay? On AWS, you have CloudTrail logs. CloudTrail everything. Put it into S3 buckets. S3 bucket storage is cheap. Okay? There are scripts out there that allow you to do clean room forensics on an EC2 instance. Basically, it's going to isolate and copy it off somewhere else. Amazon Guard Duty allows you to alert on bad behaviors and things that go on in your environment. And Guard Duty basically sends a notification, not in the sense of a push text message, things like that. That's the eventual outcome. It has a notification service that allows you to do something based on a condition being true. So if all of a sudden you have a Guard Duty rule that says you shouldn't have an any firewall rule, the second that happens, it triggers a CloudTrail event. You can then script remediation functions. So if somebody just made a change to a firewall rule that says any, the log fires, the reactive action fires, and you go ahead and roll back that rule. You can do that. Or you can alert somebody who goes and slaps somebody's hand. It just depends on the maturity of your organization. You can look for obvious stuff. Who's clearing your logs? Who's logging in with root accounts instead of your IAM accounts? Things like that. So incident response can also be done in a way that is end user facing first. That puts this warning, this message that something bad happened into the hands of the developers first, rather than an incident responder. And then finally, we can do secrets detection. If you have Git in your organization, you have passwords sitting in those Git repos. They're all in scripts. It's really ugly. It's bad. You shouldn't do it. You should scan your repos. So there's tools that are out there to do that. There's better ways to store your keys. HashiCorp is kind of a cloud on-prem thing. Amazon and Azure have key vaults. And again, this is self-service, right? You come to your developer and you say, you don't start with, hey, you checked in a bunch of open SSH keys into your code base. That's wrong. Don't do that. Because their natural question is, well, how do I do it right? The solutions. Show up with solutions. If you have DLP, API keys, things like that, these are all patterns you can search for. I mean, I literally went out to GitHub the other day, and I Googled for, the top line in an open SSH private key. And it's too small to see on the screen from anywhere, but there are 1 million instances of RSA private keys in GitHub right now. So we got to monitor for these things. You can use DLP on the desktop, across the network, things like that. So the natural question is, where do we go from here? Because in a relatively short period of time, I gave you a whole bunch of ideas. And what I'm not going to do is two things. I'm not going to say that you have to do all of these things. And I'm not going to say that if you do all of these things, everything's going to be great. Instead, what I'm saying is we have to adapt. We have to become a service provider, not a gatekeeper, an enabler. And take stock of your own capabilities, what you're capable of doing. Do you have a strong infrastructure background? Cool, go work on the EC2 stuff. Do you have a development background? Help your developers write better security, write better code security. Work on these things in small pieces incrementally, but fundamentally what I'm asking is, as you do so with a new mindset. A mindset that says, instead of saying no, gives guide rails, that drives accountability without actually stopping progress. That's what I'm proposing that we do here. And this is the evolving developer mindset. Okay? Security is everybody's job. So developers now have to truly take responsibility for their security outcomes. And that's nice to say, but that doesn't mean that we just put our hands up and walk away. It is our responsibility to bring them along on this journey. It has to be integrated into every step of the process. And the earlier you do it, through training, through checking for bugs, the sooner you do that as applications are being designed, built, and delivered, the easier it becomes, the less it costs, and the less impediment and delay you impose on your software teams and your projects. So, with that, I've got about 2 to 3 minutes, and I'll open it up to see if this has raised any questions for any of you. All right, uncomfortable silence over. Thank you. Oh, no, I got a question, yay!
Absolutely. So as with everything, when you talk, obviously, this is really focused around security and DevOps working together.
Yes.
At some point, there's going to be some type of integration of governance and managerial, or even above that. So with that in mind, how does that necessarily work? Because that isn't something that always can be automated.
So to rephrase your question, how does governance fit into these types of models?
Yes, including like management, for instance, risk assessments, things like that. We kind of touched a little bit on it in terms of some like threats met. But all in all, when it comes to essentially when you had that slide up about essentially warning break, how do you make those determinations? And how do you make those determinations as quickly as your deployment pipeline?
I would say that in a typical risk management practice where you have a set of controls, we're basically coming up with technology solutions to meet those controls, right? So I could probably give an entire talk about how threat modeling and risk management fit together, or control management. But basically, if you have a control that says you must do password handling safely, you have a bunch of technical solutions for doing that, right? And so if you have your actual risk management controls understood, and you have them actually linked to your technology patterns, then you can actually validate that as you do these things, they map back to each other. That's my best shot at answering your question. Awesome. Thank you all for your time. I really do appreciate it.